Welcome to the Read Me First online training, your guide to success with programmable logic solutions from Intel. My name is Ava. The objective of this training is to give you a starting point to quickly understand and use Intel FPGA products, collateral, and resources. This training will help you plan your development and anticipate issues before they impact your schedule. When you are done with the training, please use the link provided in the registration email you were sent to provide us feedback on the training and ways in which it can be improved. I'll remind you about that later. The next two slides show the 7 sections that will help you understand the resources that are available to you to get you started with Intel FPGAs. You can navigate easily to any section of interest using the table of contents on the left or by clicking on one of the 7 sections. In the first section, you will learn how to get started with Intel features and services by creating a My Intel account. In the preparation section, you'll learn how to download the Intel Quartus Prime software and get licensing set up for your software. The software developers section will go over the design flows that use Intel FPGAs as acceleration platforms. The hardware developers section go over the software tools that interact directly with Intel Quartus Prime, the main EDA tool for Intel FPGAs. The research section will provide you with resources you can use to help save time when creating a design. For example, you'll find links that will take you to existing designs and example code. In the support section, you will learn how to troubleshoot common problems and how to most effectively obtain technical support for Intel products and services, in addition to learning about the training resources that are available. Finally, in the last section, you'll get design tips and some important references that will help you complete your design and project successfully. But first, here is the location of our support resources website, which contains nearly all of the web pages that I will be talking about. Here is the agenda. I will start with the Getting Started section of the training. Whether you are just starting out with Intel or are a seasoned designer, we recommend creating a My Intel. You can do this from www.intel.com and click on the person icon. From there, click on the Sign Up Here URL shown on this page. Here is the basic account registration. With a basic account, you will get access to subscriptions and forums to help you with your Intel FPGA designs. You can apply to other programs such as developer and partner programs by clicking on the Here hyperlink. You might be able to create a Premier account, which will give you access to creating cases for application engineers to help troubleshoot some of your problems. Contact your local Intel FAE to verify if you qualify for a Premier account. This account will give you access to all information and support resources available from Intel FPGA. For example, you can register for additional free online training, submit a technical support question, and download software and example designs. We'll be taking a closer look at most of these areas throughout the training. Once you've completed your registration, we recommend that you go to the Customer Notifications and Subscription section of My Intel and check the boxes to receive Intel FPGA product announcements and newsletters. These emails will keep you up to date on any new products, events, or training classes announced by Intel FPGA. On the subscription page, you will decide how you would like to be notified. You can sign up to have your notifications sent to your email immediately, daily, weekly, or monthly intervals. These emails will keep you up to date on any new products, events, or training classes announced by Intel FPGA. Let's talk about preparation next. In the preparation section, I will go over the software download and getting a license. To download the Quartus Prime software or other design tools, visit the Intel FPGA Download Center, available at the link shown here or from the support section at the top of any Intel FPGA webpage. You can freely download the Lite, Standard, or Pro editions. At the Download Center, you can also download older versions of the Intel Quartus Prime and Quartus 2 software, as well as other tools, such as the Questa Intel FPGA Edition Simulation Software or the Intel FPGA SDK for OpenCL. Scroll down to the Software Selector section to choose software to download by version, by supported device family, or by software package. To quickly and easily purchase and manage licenses for Intel FPGA software and IP, use the Self-Service Licensing Center, available after logging into your My Intel account. Here, you can request a license, renew an existing license, learn how to set up a license based on the type of product you have, and change your license information. Remember that the free Intel Quartus Prime Lite Edition software does not require a license, though you may get one for the IP-based suite. Here are the steps that I will go through to get your license set up. Check to see if the software you have requires a license. If so, go to the next task of generating a license. Most of the licenses require you to visit the Intel FPGA Self-Service Licensing Center, where you can perform a large variety of functions in addition to requesting a license. You can view the number of licenses you have, maintenance expiration dates, the NIC ID registered, and the number of seats you have. You can rehost licenses, apply renewals to your licenses, add a seat to a floating license, split a floating license, view license history, assign users to a license, apply a development kit license, plus several other options. This section in the License Support Center has documents for you licensed software to get you up and running. Finally, if there ends up being a problem setting up your license, there are documents and knowledge database solutions to help guide you for your licensing scenario. Next on the agenda is going over a C++ centric flow for FPGA design. Software development on Intel FPGAs consists of using C or C++ as the design entry method using the OpenCL standard to program embedded soft or hard processors, and to use your FPGA platform as an accelerator to speed up functions that might be too slow on commonly used hardware. Use any or all three software development methods on your FPGA. With the One API programming model, developers can iterate and complete POC designs quicker through emulation and reports by performing functional verification and performance tuning respectively before having to perform a long hardware compilation. Get runtime data across their host and accelerators through vTune. Reuse source code across multiple hardware architectures and vendor platforms. Note, code will need optimization to be performant on a different architecture. Debug and train new developers faster due to the commonality of sequential programming languages. The One API product provides easy access to all of Intel's heterogeneous architectures through a unified language. The One API toolkit uses the DPC++ language, which is based on SYCL, a bunch of libraries and analysis and debug tools. One API product for FPGA use is enabled with just the DPC++ and the analysis and debug tools. Quartus is provided under the hood, as well with LLVM, providing the layered approach framework for developing the tools. There is a runtime based on DPC++, which takes care of data passing from the host to the various devices been targeted for acceleration. Check out the web page located here for more information on Intel One API-based toolkit for FPGAs. Intel OFS enables software, hardware, and application developers to use standard interfaces and API to accelerate workload development and enable code reuse. Port existing workloads to the accelerator functional unit region to proliferate across Intel OFS-based platforms. Utilize workloads provided by Intel and third parties directly or further customize existing workloads. Deploy bare metal, virtualized, or containerized applications with data center class management for network functions virtualization, SmartNIC, virtual radio access network, financial services industry, and more. Build application-specific FPGA interface managers with modular and composable code, allowing a take-and-tailor FPGA design approach. Leverage open-sourced and upstream software code delivered via Git repositories with native support from leading vendors. The AFU is the algorithm or processing unit that provides FPGA-based acceleration and/or CPU offload. Reference FIMs provide platform management, functionality, clocks, resets, and standard interfaces to the host and AFU. The Intel OFS kernel drivers are the first layer in the FPGA software stack. The OPC libraries are lightweight, user-space libraries that provide abstraction for FPGA resources in a compute environment. High-level design application abstracts the FPGA hardware and design flow, enabling users to design FPGA custom hardware with familiar programming languages and development environments. With the trend of offering entire systems on a chip, Intel goes further by offering you to create tailor-made systems to suit the needs of your specific design by allowing you to add the peripherals you need to your embedded system. Even with the programmability of your FPGA embedded system, Intel offers an embedded software ecosystem that is similar to all other embedded software development environments. If you are already familiar with an embedded flow environment, then you will be able to do FPGA embedded development without any difficulty. To address this trend head on our SoC FPGA, which integrates a hard ARM processor with the fabric of today's most advanced FPGA, enabling embedded designers to develop customized ARM-based solutions. ARM has become the most widely used and preferred processor for embedded processing design. The popularity of ARM's processor and its ecosystem is second to none in the embedded industry. Intel also offers a more lightweight embedded processor if an ARM solution is more than you need. The Neos 2 processor is a classic pipelined RISC machine containing 32 general-purpose registers. It has 32-bit data and instruction paths, with separate and configurable instruction and data cache sizes. The processor has tightly coupled memory options to allow you to directly connect the processor to on-chip memory and avoid potential contention on the system interconnect fabric. There is a branch prediction option and on-chip hardware acceleration capabilities, which allow you to do multiplication, barrel shifting, and rotation in hardware instead of software. The processor includes hardware for handling exceptions, including hardware interrupts, and optionally supports a new peripheral region mechanism to indicate cacheability. The processor also has an optional MMU and MPU if you're using an operating system like Linux that requires them. Finally, it has the ability to connect to custom instructions and to debug through JTAG. The Neos 5 is based on RISC-V RV32IA, designed for performance with atomic extensions, 5-stage pipeline, and AXI4 interfaces. Read the Neos 5 processor reference manual to learn more about features and performance benchmarks. Visit the overview pages for both the ARM SoC and Neos for more information. Neos 5M is the first processor in the Neos 5 embedded processor series. It is a 32-bit microcontroller based on the RISC-V RV32 ISPEC with a 5-stage pipeline. With the initial release of Neos 5M in Intel Quartus Prime Pro 21.3, all devices in the Pro Edition are supported, such as the Intel Agilex, Intel Stratix 10, Intel Aria 10, and Intel Cyclone 10GX devices. It is easy to create a processor and peripheral solution with the Neos 5M processor using the traditional hardware tool flows like Platform Designer and the Intel Quartus Prime Pro Edition software as needed for your production solution. Neos 5M supports industry standard interfaces like AXI4 for external connection. Currently, software development is enabled using the open source ecosystem. You can build your application using command line interface or the Eclipse IDE. Additionally, you can use a third-party IDE of your choice for software development. Please note, the Eclipse CC++ development tooling and the RISC-V toolchain are not included in Quartus. However, we provide instructions to download and set them up in the Neos 5 documentation. You can debug your application using supported OpenOCD Eclipse configuration. OpenOCD is an open-source on-chip debugger that aims to provide debugging for embedded target devices and is included in Quartus. To learn more about software development and debug using Eclipse-based OpenOCT, you can refer to the Neos 5 Processor Quick Start User Guide. For an out-of-the-box user experience for software development on the Neos 5 processors, an integrated development environment by a partner will be coming soon. It will have basic debugging capabilities and will be included with Quartus. The IDE will have an Eclipse-based integrated development environment, trace support, custom instruction display and trace, and the RISC-V toolchain included to kick-start your software development. The partner IDE will support common debug on Intel PSG ARM and Neos 5 processors with the capability to debug complex applications in the same environment. More information about Neos 5, refer to the Neos 5 Quick Start Guide and Reference Manual. There are also 3 quick videos that go over creating an example design, setting up the open source's software, and software development. These quick videos can be found on the Intel FPGA YouTube channel. The Intel SoC Embedded Design Suite is a development environment that includes the ARM Development Studio Toolkit, hardware-software handoff which helps build the various bootloader stages, and a number of tools to help with Linux development that include some pre-built Linux kernels. We also work with the community portal through rocketboards.org. Bare metal tools are also available if you don't need an operating system for your environment. We also include some design examples to get you going. The Development Studio tool from ARM is Eclipse-based integrated development environment, which includes standard features that you would expect from an IDE such as file editing, project management, and a debugging environment necessary to connect to the processor to manage your software development in real time, such as probing for register contents, monitoring variables, profiling, tracing, and cross-triggering code. Eclipse-based IDE provides a great workbench with ARM's assembly editor and project management tools. Build, compile, and build code for high performance or small footprint with included ARM compiler 5 or 6. Debug bare metal, Linux, and Android application code with low-cost Intel FPGA download cable 2. FPGA Adaptive Debug. The FPGA Adaptive Debug is a powerful feature that gives a system-wide view of the SoC, allowing you to cross-trigger between the hard processor system and the FPGA with ease. Program Trace. View timeline charts with Core Site System Trace macrocell. Optimize, and make your Linux or bare metal application more efficient with Streamline and Trace. Program Trace. Also view heat maps to see how frequently functions execute. Application Performance Analysis. Visualize the performance bottlenecks in your embedded software using Streamline. Support for bare metal, Linux, and Android applications. For more information, visit the overview site that provides a brief introduction to the Embedded Design Suite. The Getting Started site lists the features included in the software along with resources, where to get the documentation, licensing, and downloads so you can get started. Let's go over the section for hardware developers next. Intel provides a complete suite of development tools for every stage of your design for Intel FPGAs, CPLDs, and SoC. Whether you are creating a complex FPGA design as a hardware engineer, modeling a digital signal processing algorithm, or focusing on system design, Intel has a tool that can help. For the more traditional approach to designing into Intel FPGAs, you will use the Intel Quartus Prime software, where you can do schematic designs, or a hardware description language such as VHDL or Verilog, or a combination of the two design entry methods. Intel also boasts a collection of intellectual property of some of the more commonly used tasks that are targeted specifically to Intel FPGAs so that you can reduce the time needed to get your project going. If you are a digital signal process engineer, you can use MATLAB code to create your and target Intel FPGAs. Intel also offers a high-level synthesis flow where you use C or C++ as your design entry method. I will go over each of these products in the following slides. There are 3 versions or editions of the Quartus Prime software: Lite, Standard, and Pro. The Lite edition can be downloaded and used without a license, but it has limited device support and does not include all the features of the other editions. The Standard edition supports all device families and all existing Quartus features and tools, but it requires a software license for use beyond an initial 30-day trial period. The Pro edition includes a number of new features, including a new synthesis engine and enhanced tools for working with Intel's most advanced FPGA devices. Going forward, the Pro Edition only supports ARIA 10 and newer devices. To download and install any edition of the software, click the middle link to go directly to the Quartus Prime Download Center, or click the bottom link to jump directly to the Quartus Prime documentation page for in-depth information about the features. We refer to the Intel Quartus Prime software as a fully integrated design tool because you can do everything you need to do to create an FPGA design within the software without the need for any other tools. The software gives you the ability to enter your design in multiple ways. Once entered or created, the software will then synthesize your design into logic and place and route your design using the resources of your target device. You can then use the built-in programmer to program an FPGA device with your design. For your simulation needs, the Intel Quartus Prime software works well with many third-party simulation tools. To get started if you do not have a simulation tool, The Questa Intel FPGA Starter Edition and Questa Intel FPGA Edition tools can be downloaded from the Intel FPGA website. The Starter Edition is free and included in every installation of the Intel Quartus Prime software. To see a comparison between the tools and the extra features of the full edition, visit the Questa Intel FPGA page, linked here. Please visit the overview site for more information regarding Intel Quartus Prime software. Intel and our partners offer a large selection of IP cores optimized for Intel FPGA devices. IP cores are provided by Intel in the IP base suite, included with the standard and pro editions of the Quartus Prime software. The IP base suite is installed with the Quartus Prime Lite edition, but its use requires the purchase of a license. All Intel FPGA IP cores are rigorously tested and optimized for the highest performance and lowest cost in Intel FPGA devices. IP cores can be parameterized, allowing you to customize them specifically for your application. The evaluation feature allows you to simulate the behavior of an IP core within your system. Generate a time-limited device programming file to verify the functionality of the design and hardware and evaluate its size and speed before you decide to purchase a license. Visit the IP webpage links provided here to learn more. The DSP Builder for Intel FPGAs is a high-level tool that enables MathWorks Simulink to generate FPGA RTL hardware. The DSP Builder is a collection of device-optimized Simulink blocks which allows you to build and verify the DSP model you need and then, at the push of a button, generate an RTL implementation of the model that can be easily integrated in the Intel Quartus software to be compiled into an FPGA bit stream. In the Simulink tool, DSP Builder enables high-level design exploration of performance and resources. It allows verification through Simulink as well as automated Questa simulations. And there's the ability to speed up simulation using FPGAs through hardware in the loop. Please visit the overview site to learn more information about DSP Builder for Intel FPGAs. The Intel HLS compiler can be used to target any Intel FPGA, generating optimized RTL code for that specific family. The command line executable for the compiler is I++, and it will automatically build an IP from your CC++ source that can be integrated into a traditional FPGA design using FPGA tools in the Quartus environment. You can instantiate the generated IP in HDL. You can use Platform Designer, a system integration tool, to connect to other FPGA components. You can even add the IP as part of the Intel FPGA SDK for OpenCL board support package, so you can use OpenCL to develop your system. The goal of our HLS compiler is to provide a highly productive tool for you to create an FPGA IP using traditional software like design flow. The compiler allows you to leverage standard software environment, yet allows you to achieve the performance on par with HDL implementations with a small 10% penalty in FPGA resources. Because it is so much faster to develop in software, the HLS use model allows users to develop and debug the system in the software world, and the HLS bridge the gap between the software and hardware worlds, leveraging the productivity flow wherever possible. First, a user has C code that he or she can compile and verify with a standard GCC, G++ compiler. The output of that is an executable that is run on a host. If there are functions that needs to be accelerated by putting them into the FPGA, the developer can then compile the same exact C code with the G++ makefile compatible Intel HLS compiler. The resulting output of the compiler is an IP block that can be integrated with other FPGA logic in the Quartus ecosystem. The Intel HLS compiler will also generate a host executable that will automatically co-simulate the IP in a hardware simulator, such as Questa with the software test bench. Please visit the HLS compiler overview webpage for more information. Next, I will go over research resources that we have available. In the research section, you'll get recommendations on some resources you can use to help save time during the design process. You will learn how to access design examples and reference designs, how to access our Technology Center, how to purchase development kits, how to download literature, and where to go to find additional information. Design examples provide you with a documented example as a starting point for you to create your own functional designs. Intel FPGA engineers have developed a variety of useful design examples for many common applications, such as how to instantiate internal memory and other IP, and how to use a Neos 2-soft processor as a web server. Use the link shown here to search for and view design examples organized into a number of different categories, including DSP, interface protocols, and verification. In many cases, there is no better way to test or implement your design than with a pre-existing platform from Intel or one of our development kit partners. Intel FPGA's development kits come with everything you need to easily develop and test your design on a wide variety of applications, devices, and technologies. Development kits come with extensive documentation to make it easy to get up and running quickly. The links provided here will take you to a complete list of the development kits available and give you access to all the content available for a particular kit. You can start downloading documentation and designing for a kit today. To get started even faster with a development kit or a particular IP core, you can download complete project templates from the Intel Design Store. The Design Store is constantly updated with new designs that work right out of the box for selected development kits, device families, IP cores, and versions of the Intel Quartus Prime software. Unlike the design examples mentioned earlier, Design Store templates integrate directly with a particular version of the Intel Quartus Prime software, usually requiring only a compilation to start running the design on a board. Intel FPGA offers a wide range of devices. The devices product page, linked here, should be your first stop for device and family-specific information. There, you'll find brief descriptions of each device family, along with links to product-specific pages containing descriptions and capabilities of each device. To help choose the best Intel FPGA device for your needs, you can use the Device Selector tool. Filter the list of devices based on your design criteria. You can also compare the features and options available in different devices. Along with the Device Selector are the IP and Development Kit selectors. Use these tools to search for IP and development kits available from Intel FPGA and our partners. These tools make it easy to narrow down and compare devices and products to help you select exactly what you need for your design. The Technology Center provides you with quick access to solutions for many of the latest technology applications and challenges. Some example technologies linked to here include security solutions, optical FPGA data paths, and high-speed transceivers. After selecting a technology, you can obtain information on how to implement that technology with Intel FPGA devices, how to overcome common design challenges, and learn about additional resources available for more information. Intel FPGA maintains an extensive collection of documentation for all devices, IP, and software. At the Intel FPGA documentation website, you can find application notes, data sheets, user guides, and other material. You'll also find a number of handbooks. A documentation handbook is a grouping of various types of literature under a single category. For example, the Intel Quartus Prime Handbook provides you with all applicable literature on the Quartus Prime software. You can search for and view any document in your web browser or download in standard PDF format. Other useful types of documentation are user guides and white papers. User guides are detailed technical documents that help you use certain Intel FPGA devices, selected IP, and development kits. White papers are shorter technical documents that cover a specific end market or technology feature or how to use a specific Intel FPGA product feature. You can find user guides and white papers at the links provided. Next is the support section. In the support section, you'll learn how to troubleshoot common problems and how to most effectively obtain technical support for Intel FPGA products. You'll find out about the knowledge database, the Intel FPGA community forums, rocket boards, support, and training material that is available. The knowledge base is a good place to start when you have a question or run into a problem. If someone has encountered a similar issue before you, the knowledge base may already have it documented with a solution or workaround. If you run into a strange error message, try entering it here to see if it is a known issue. You can also find known documentation issues here. To access the knowledge base, click the link provided here and scroll to the bottom of the page. You can also navigate here from the support section at the top of all Intel FPGA web pages. The Intel community is a freely accessible community forum that brings users together to share their knowledge and ideas related to Intel FPGA products. If you have a question, you can submit it to the forum and receive answers from other Intel FPGA customers across various companies around the world. FAE are also known to post and reply in the forum from time to time. You can access the forum going to the Intel FPGA Support Resources page and clicking on Intel Community. One of the most common uses for Intel SoC devices is to run applications in a variant of the Linux operating system. To help you with setting this up, Intel FPGA offers a separate website called rocketboards.org. From initial setup through final design release, the website makes it easy to get help and information for Linux from the embedded systems community. You can find documentation, download projects and code examples, and even submit your own projects for use by others in the community. The rocketboards.org website is your one-stop shop for everything Linux on Intel SoC devices. A Premier account gives you access to submitting support cases via your My Intel account dashboard. With a Premier account, you can submit and keep track of your cases that you have. You will be in regular contact with an application engineer to resolve the issues that you currently have. If you are new to Intel FPGAs or are an experienced FPGA design engineer, check out what the training department has to offer to help sharpen your skills. Intel FPGA offers a wide variety of technical training to ensure you have the skills necessary to successfully complete your FPGA design. We offer training in a number of different formats to suit every type of user. We'll look at the different training types in detail on the following slides. Intel FPGA recommends that you attend training before you start your design to get the most out of our products and services. The training team has developed many ways to deliver content to you. We have live, in-person, and web-based classes. Your company can request an in-person class or a private, web-based class as well. The training team also has hundreds of on-demand e-learning videos that you can access from Intel's website. Intel also has an FPGA channel where we host most of our on-demand e-learning videos, along with quick videos which are roughly 5 minutes in length that deal with a specific topic. Intel FPGA offers hundreds of training courses, so you may wonder, what courses do I need to take? Or, which course is right for me? Or, in what order should I take training courses? To help you answer these questions, all Intel FPGA training is organized into 7 basic curriculum made up of recommended courses along with optional, specialized training. The curricula correspond to our recommended flow for learning all about Intel FPGA devices, tools, and services. Once you select a curriculum, you will see the list of recommended and optional courses to take. The courses are shown in the order in which Intel FPGA recommends they be taken, but of course, these are only recommendations. You may take training classes found in any curricula in any order you wish. Prerequisite and follow-on training classes are listed on each individual courses page. Intel FPGA's instructor-led training classes give you the opportunity to take a course in person with an experienced instructor in a classroom setting. You can ask questions and receive immediate answers. You'll practice your newly learned skills through interactive lab exercises using development tools and kits. Public instructor-led web-based classes are currently free of charge. You can also register for an on-site, private classes for an additional cost. As part of your purchase agreement, you may have training credits you can use to attend instructor-led training classes. See the first link here to learn about training credits and how to use them. You can view the complete list and schedule of instructor-led courses using the link above. If you are outside of North America and wish to have an in-person instructor, please contact one of our training partners to arrange for a local training class. You can see a list of our partners at the final link on this slide. The web-based classrooms give you the opportunity to attend a live, instructor-led training from the comfort of your home or office. Virtual classrooms are taught over the internet through a combination of Microsoft Teams and WebEx, allowing you to interact with an experienced Intel FPGA instructor to get your questions answered from anywhere in the world. Virtual classroom content is identical to the live class. Audio is conducted through the interface or through a separate, toll-free telephone conference call. Classes are taught in 4.5-hour sessions across 2 consecutive days. Virtual classrooms include all the same lab exercises that you'd go through in a live class. The best part is you don't even need to install any software. You'll connect remotely to an already configured Intel FPGA training computer. The lab exercises are tailored for the virtual classroom, so you'll even be able to use attached development kits if they are part of the class. If you're watching this training, you're already familiar with the first type of training available from Intel FPGA: online training. We offer hundreds of online training classes available on a multitude of topics. Classes range from short 20 to 30-minute presentations to full-day class replacements. Many of the online training classes include software demonstrations where the instructor actually shows you how to perform actions in the Quartus Prime software or other tools. All of our online training classes can be viewed on any computer, and most of them can be viewed on your favorite portable device. They can also be downloaded for offline viewing. The online training classes are easy to navigate. You can start and stop them at any time to practice what you've learned, and you can skip directly to the sections you're interested in. All blue hyperlinks are active directly in the training, allowing you to immediately jump to linked web pages and other online resources. There are many short videos around 5 minutes in length called quick videos. These videos present a single, concise topic about a particular feature of Intel Quartus software or Intel FPGA devices. The quick videos can be found on the Intel FPGA Quick Video website or on the Intel FPGA YouTube channel. As mentioned earlier, the training department has training partners outside of North America if you wish to have in-person live sessions in your area. Please consult the web page listed here for contact information. You can subscribe to Intel FPGA's YouTube channel, which is constantly updated with in-depth technical how-tos and demonstrations on a large variety of topics. One useful feature of the Intel FPGA YouTube channel is the Engineer to Engineer playlist. This playlist contains over 200 short videos, most less than 5 minutes, created by Intel FPGA engineers and field application engineers. The videos are meant to introduce you to a topic and direct you to where to go for more information. Subscribe to the YouTube channel to stay up to date on all the latest videos. Finally, I will talk about some of the design resources that are available. This is the final section, Design Resources. In this section, you'll get some design tips and important references that will help ensure the success of your project. We'll look at the initial design review, calculating device power usage, pin connection guidelines, and design solutions partner. To best ensure the success of your project, Intel recommends that you first educate yourself and your team using the resources previously discussed. This will allow you to create the most efficient design possible for Intel FPGA devices and reduce your time to market. Second, stay on top of your design project by anticipating needs early and planning ahead. Make use of existing solutions such as IP, reference designs, and development kits. Understand the roles of your team members and any partners you choose to engage with. Track the progress of not only your responsibilities, but the progress of your team members as well. Finally, consider contacting your local FAE for an initial design review. This is a good way to proactively avoid pitfalls or other issues. And don't forget the Intel FPGA Support Resources webpage to find information on particular design resources of your interest. Here you will find information to help you understand power consumption considerations when planning system designs, estimating power requirements throughout the entire design flow, and meeting demanding power requirements. This site helps you understand your power requirements described in a number of different phases, from choosing a power tree, power estimation, to power distribution and thermal considerations. Check out the many application notes, user guides, design examples, and reference designs listed on this page. Here you will find information on how to ensure signal integrity and power integrity in your high-speed designs. Similar to the Power Solutions page, this site lists many application notes, user guides, design examples, and reference designs to help you understand your board's signal integrity needs. While every device family has its own device handbook, it is often helpful during board development to have a detailed pinout table for a particular device. You can find detailed information about device pinouts for every device in every device family at the first link. Verifying pin connections prior to committing to hardware is a critical step that will help reduce the chance of needing a board respin. You can find pin connection guideline documents through the link here, which should be read and followed when you develop your pinout and when you review your pinout prior to the final layout of your board. Intel FPGA provides schematic review worksheets for each device family intended to help you find mistakes in your schematic and adhere to design guidelines. These worksheets are based off of the respective device pin connection guidelines and other referenced literature applicable to board-level pin connections that need to be considered when you finalize your schematic. Intel FPGA also provides a layout review worksheet intended to help you find mistakes in your PCB layout. This worksheet is based on guidelines that can be found at the Board Design Resource Center and other referenced literature applicable to board layout techniques and practices that need to be considered when you finalize your PCB layout. All worksheets are available in .doc format, allowing for easy editing and entering of information for your design. Depending on your resources and your experience level, you may want to consider outsourcing part or all of your project to a design service partner. Design service partners can do the design work for you. For example, they can create the VHDL or Verilog HDL code based on your specification. Members of the Intel FPGA Design Solutions Network are independent design partners who have extensive experience designing with Intel FPGA products. Use the link provided here to review the partners available and contact one of them. This concludes the Read Me First training. To summarize, as you have seen, there are lots of resources available to you from Intel for use before, during, and at the completion of the design process. Use this training as a guide for quick access to all of these resources. We want to ensure the success of your design with our products and services, so take advantage of all we have to offer. Your local distributor can be a great resource if you need further technical support. If you can't find the answer to your question or problem using the resources described earlier, contact your local distributor. Intel's distributors have local field application engineers, known as FAE, that are regularly trained to support Intel FPGA products. Distributors may offer other services as well, including design consulting. Contact your local distributor to find out what services are available in your area. Intel provides multiple avenues in which to learn about Intel FPGA products. There is the Intel FPGA YouTube channel, which contains 5-minute quick videos along with longer, more in-depth training videos. There is the Intel FPGA training website, where you can access e-learning courses made up of narrated slides presented in an interactive player, some courses with labs and demos. Lastly, you can also enroll in a live instructor-led course presented either in person at an office local to you or virtually over the web. All instructor-led courses have hands-on labs exercises to practice the concepts you learn. If you need more assistance, Intel FPGA provides many self-help resources for you to access. For example, there are web pages called landing pages dedicated to specific FPGA technology like and high-speed interfaces. You can also view and post questions to the community forum, which is monitored by skilled Intel FPGA applications engineers. The Intel FPGA training team is always looking to improve our material and welcome any feedback you may have. Please email fpgatraining@intel.com with any of your thoughts or comments. This concludes the training. Again, my name is Ava. Thank you and have a good day.